Hello, this is the 4-week fall 2017 math course, and we will go over one of each problem type to see how we solve these. And you have the answers to all these so you can check. So week 1, we have unit conversions as the first type. Mr. Blue drives in 33 minutes, and it's 20.9 miles away. The speed in miles per hour. We know it's 20.9 miles over 33 minutes. We can times that by 60 minutes in 1 hour. That does not look right. But anyway, we'll multiply across. That's good. And we get 38 miles per hour. So as long as the units look right, you know you did it right. Number 3 is a system. Recall that we have substitution and elimination. Because that first one has the y equals, it's probably easy to just plug the x squared in here. So we substitute in, then we're going to have to distribute the -4 over there. And now whenever we have x terms and x squared terms, we have to get everything to one side, factor, and solve. So we move it all over. Whenever the number in front of the x is not a 1, we want to try to make it a 1. So we factor out the 2, divide both sides by 2. 0 divided by 2 is still 0, so it doesn't change that. And then we want two numbers that multiply to -8 and add to 2. So it's going to have to be 4 and 2. So then we get that x is -4 and +2, but that makes no sense. Okay, so then x would be -4 or x would be 2, but they tell us x is greater than 0, so we only want the one where x is 2. So then we bring that back up, and that means we can sub in into this first equation. If y is x squared, then y is 2 squared, or y is 4. And so xy, the thing we want, is 2 times 4, or 8. 4 is kind of the same. Number 5 is another system. Now they're both y equals, so we want to set those equal. We set x squared minus 10x plus 21 equal to x minus 7. Again, whenever we have x squared and x terms, we move everything to one side so we can factor and solve. We want two numbers that multiply to 28 and add to -11. So x would be either 7 or x would be 4. And then in each of those, we get a corresponding y value. So when x is 7, y is 0. When x is 4, y is -3. So the sum of x and y here is going to be 7. And over here it's going to be 1. So the answer could be either 7 or 1. Either one works. Six is the same. 7 is our completing the square. We have to only have squared terms on the left-hand side of the circle equation. The trick is you take whatever's in front of the x or the y term and you divide that by 2. And that's what comes down here. So it would be y plus 5. But if we FOIL that out, y plus 5, we would get y squared plus 10y plus 25. So up here we have to add a 25 to both sides so that now on the left-hand side when we brought that down it was the same thing. So now we know that the center is 0, -5 and the radius is 7. Sometimes they'll ask about the center there too. But we of course know x minus h squared plus y minus k squared equals r squared is our circle equation, where hk is the center and r is the radius. So all the rest of those are kind of the same. We'll just have to complete the square twice on those, once on the x's, once on the y's. Week 2 coming up next. We want to recall that we always want to clear fractions first. We have a big system here. F is this one, G is the other one. When is F equal to G? So we set them equal. And then times both sides by -3. So I would clear that fraction straight away so that when I FOIL out x minus 4 squared, I don't get any issues with it. So then we FOIL it out, and now again when we have an equation with both x's and x squareds, we have to move everything to one side so we can factor and solve. And when we factor it, we get that it's either x minus 7, x minus 4, so it's either 7 or 4. We set each factor equal to 0 to get our solutions. 13 requires us to set up our system, create it from the garden here. The length is 13 yards longer than the width. So if we call the width x, this is going to be x plus 13. When we multiply those together, that will give us the area. Again, we're going to have an equation with x terms and x squared terms, so we have to get everything to one side, factor, and solve. 114 is kind of an odd thing to deal with, but it ends up that if we get 6 and 19, it'll work. So the way you would factor that is try 2, then 3, then 4, then 5, then 6, till you get something that gives you also the gap of 13, but the product of -114. We only care about the positive one because you can't have a negative length. So the dimensions will be 6 by 19. And because they're asking about the length, not the width, it would be the 19. And at any point, feel free to pause the video, obviously, to write these down. 14 is the same. 15 we'll look at. The mean score of 9 players was 18. We can assume they all had the same score. So altogether, their scores add up to 162. We take out the highest, and we're left with 8 times 16 points total, which is 128. So if we subtract those out, we get 34 as the missing piece for the high score there. 17, we have to change up this complex number. Recall that we can't have i's on the bottom of a fraction, so we have to times by the conjugate, which is the same thing, just flip the middle sign. So we get 28 plus 21i minus 8i minus 6i squared over 49 plus 4. It's minus 4i squared, but I squared is -1. So that's going to be over 53. The top is going to be plus 13i, and then 28 minus 6i squared is the same as 28 minus 6 times -1, or 28 plus 6, or 34. So that's what I'd say. So again, we always sub in I squared. We sub in for that with a -1. Next one's the same, and 19 is another system. When in doubt, always clear fractions. So I would cross multiply here. You put that over 1 and cross multiply and get that x equals 4y. And then sub that into the second one. Distribute the 3. And then minus the 3y's from both sides. It's probably the easiest way to do it. So never deal with fractions. Always get rid of those fractions up front. It's important. Week 3, some more word problems, some more fractions. And up next, a lot of words. So 40% of the sirloin was sold at the higher price. So if there's 190, we times that by 0.4, and we get 76 pounds sold at the higher price. And we can do 190 minus 76 to get 114. That's the rest at the lower price. The total revenue, we do the 76 times the 9 plus the 114 times the 5. And we should get 1254. Yep. So just a bit of percents there to deal with. 23 we'll look at as well. 95 pounds are sold at $8 per pound, so we times that out to get the $760 they made there. The next time they sell X pounds at $7 per pound, so that would be 7X is the amount generated there. If those two amounts are equal, we could solve and we get either 108 or 109. You can round either way. One rod is in a square. The other side one is an equilateral triangle. If each side of the triangle is 3 inches longer than the square, so if we make the square sides x, each one of these is going to be 3 plus x. But we know the perimeters of each have to be equal, so we can add up over here and have 4x, and that has to equal 9 plus 3x on the other side. So we can solve for x and get that it's 9. And then we can plug that back into either figure. So if we choose the first one here, we have 4 sides, so 9 times 4 is 36. And down there, 27, we want to change this expression to another one where we have just a single number over this. So we want to times this one over here by x plus 3 over x plus 3 to get that common denominator. Just that second term. And we can do that because x plus 3 over x plus 3 is just 1. So what we get is 4x plus 14 minus 4 times x plus 3 all over x plus 3 squared. The x's will cancel out, 4x minus 4x, and we're left with 14 minus 12 over the bottom, which is 2 over the bottom. So the answer is 2. So that's one of those make it look like the answer. We take what we have there and we turn it into one of the answers. 28 is the same. 29, very important here. We have a fraction. We want the value of 4x squared. Remember, that's a clue. Whenever they ask us for an expression, we always want to find it directly. So when I cross multiply here, I get x squared minus 10x plus 24 equals 5x squared minus 10x. If I move the x squared over and I add 10x to both sides, magically the 10x's are going to cancel. and I get 24 equals 4x squared, and then I stop, because that's what I want. Don't need to solve for x. X is some messy thing. Root 6, actually. But we don't care about that. We just want x squared. So always use those clues and try to find the values directly. Week 4, last piece here. Proportions. 1/4 of an inch is 25 miles. If the distance on the map is 1 7/8 inches, what's the distance in kilometers? So the first thing I have to do is multiply that out. Times 1/4 of an inch is the same as 25 miles. And then I can times 0.6214 miles per 1 kilometer. And if I multiply straight across, all my units will cancel and I'll be left with kilometers. That's the old chemistry way. And we should get 301, about 302. You could set it up as individual proportions. So convert the inches to miles, then do a separate one, convert miles to kilometers. That's fine too. This one just saves this thing. Next, we'll look at 33. 33, the ratio of x to y is 5 to 3. Which means that if we cross multiply, 3x equals 5y. And over here, x plus y equals 120. Again, I would not want to deal with fractions. So I would not solve for y and plug in. If I'm going to plug in, I would times this whole thing by 3. So that when it comes time to plug in, no fractions. So because 3x is the same as 5y, that goes in there. 8y is 360. And we divide by 8 to get that it's 45. And of course they want the value of x. So we have one more step. We put that back in this equation for y. 5 times 45 over 3 gives us that x is 75. And don't be obtuse like I just was and plug it in the better equation. Plug it in the other one. X plus y equals 120. That's a better place to plug in. Always do it the easy way. Continuing on, 35 gives us two equations, and it says they represent the same line. So we want to make them more the same. Don't know what c is, but to turn x into 3x, I would times this whole first thing by 3. And it becomes 3x plus 9y equals 36. The other equation is 3x plus 9y equals c. So the c is where the 36 is, and it has to equal that. So always compare like terms there at the end. Jumping down to 38, these two equations are perpendicular lines. The number one thing we think of when they say perpendicular is that they slopes are the opposite reciprocals. So I put this into y equals mx plus b form, and I get that the slope there is 2. So the slope of this one is going to be negative 1 over 2. Solving for y here, we get that y is negative k over 6x plus 8 over 6. So now if the slopes are equal, negative 1 over 2 has to be equal negative k over 6. I set those equal, cross multiply and solve, and get the k is 3. So that's why 38 is 3. So find the slope of the one, then get the negative reciprocal, and set that equal to the slope of the other. Last page here. Here's a circle. The hint says draw it out. Don't be lazy. Do that. From the equation, we can know that the center is negative 4, 2. And then over here, come on, you got to label that better. That's negative 4, comma 2. Point P is on the circle, and the coordinates are negative 10, comma 2. So that's our circle. And then PQ is a diameter. If that's our P that we just labeled there, if we connect it here straight across, that should be horizontal. Straight across, we know the radius is 6 because r squared is 36. So if that's 6, that's also 6. So we go 6 units to the right. Negative 4 plus 6 puts us out here at 2, 2. That's why it's D. 41 is similar, but with that one, it's going to be vertical when you draw the diameter. So, but again, just definitely draw it out. 42 is a tough one here. T is a constant. If the equation has no real solutions, what could be the value of T? No real solutions means imaginary solutions. And that's a hint that we would be using the quadratic equation, which you have to know. Negative b plus or minus the square root of b squared minus 4ac all over 2a. In order to not have real solutions and to have imaginary ones, the stuff inside the root here would have to be negative. Right? If that whole thing in the root is negative, then we get i's, then we get imaginary numbers. So we want that whole thing in the square root to be negative. And then we could sub in for b, a, and c and solve. And we get that 25 minus 8t is less than 0. 25 is less than 8t. 3 point something. 3.1 is less than t. So, or t is greater than 3.1. So if t has to be greater than 3.1, there's only one answer that can work. So whenever we have quadratics, terms with x squared in them, we want to know how we would get imaginary solutions. So that concludes the review here for these problems.